Mr. Heffernan here, and this is a quick video on significant digits. Okay, significant digits can be called sig-digs for short, and they are very important in labs, in medicine and engineering, and business. So sig-digs are any measured value that is not a place holding zero. Therefore, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are always significant. And 0 is significant too, unless it is acting as a placeholder. Sig-digs, when rewriting a number in scientific notation, you only keep the sig-digs. You drop the place-holding zeros. So for example, 145,000 meters, you would drop these 3 zeros because they're only acting as placeholders. Rule number 1, just to break it down into small rules, non-zero values are always significant. So for example here, 150 centimeters, the 1 and the 5 are not zeros, so we keep them when we write it in scientific notation. Down here, 0.00159 seconds, the 159 are not zeros, so we keep them. And in both cases, we drop the place-holding zeros. Okay, next, 0 between two non-zeros is also significant. So for example, 150,900 kilos. The 0 here between the 5 and the 9 is significant. We can't drop that. And when we rewrite it, we get 1.509 times 10 to the 5. If we accidentally did drop it, then we would have 159,000, which should be incorrect. Down here, the next example, 0.000150009. So these two zeros are between the 5 and the 9, so we definitely keep them. But we do drop the place-holding zeros at the beginning. Okay, let's say in this case here, rule number 3, a 0 after a decimal, so a decimal mark, and also after some other significant digit. That means this is not a place-holding zero and we have to keep it. So for example, let's say Ant-Man and Wasp measure several pencils to the closest micrometer. So here we got a bunch of pencils, and let's say they get these values, 9.1234. This is an easy one. They're all non-zeros, so we keep them all. 8.99007. We keep the 0 because it's between two other digits, so that's an easy one too. Now it gets a little tricky. 8.8970. So this 0 is not a placeholder. It's actually part of a measurement, so we have to keep it. We do not drop it. So I see a common mistake is people will drop the 0 if it's at the end, but you cannot do that. All right. And lastly, 9.10000. This is a very fine, very precisely made measurement. It is to the 4th decimal place. You cannot drop those zeros. You must keep them. Okay. A 0 may be part of an exact value, and that makes it significant. So for example, a century is 100 years long, and therefore we could say at the time is 100 annum, or 100 years. And that's 1.00 times 10 to the 2 annum. So you don't want to write 1, because if you just write 1 with no 0.00, that could be anything from 50 to 150 years. You want to show how precise, how fine your value is by keeping those decimal places. And then down here we have a 400-meter dash. Okay, so when they measure these for the Olympics, they may be 399.998 or 400.001 meters. They're very fine, well-measured values, so they are exactly 400 meters. So in that case, you have to keep the decimal places. A 0 acting strictly as a placeholder is not a significant digit. Zeros due to rounding and approximation are non-significant placeholders. So usually you get zeros acting as placeholders due to rounding and approximation. So for example, a trail may be 5,489 meters long. The sign at the beginning of the trail may say that it's 5,500 meters. So obviously they've rounded it to the closest 100 meters. Which means on the sign, only the 5 and the 5 are significant, and these two zeros are placeholders due to rounding. The city of Barrie has 151,239 people today, but the sign may state that there's 151,000 people, and these zeros are obviously due to rounding, and we have rounded to the closest 1,000 people. So these zeros, we'll have to remove them when we rewrite it in scientific notation. So in summary, significant digits are any digit except a place-holding 0. Significant digits are very important in science, medicine, and engineering when determining how precise measurements are and how accurate and truthful results may be. Professionals need to know how much they can trust numbers to know the uncertainty and margin of error measurements and results may have. We do not want bridges to fall down or for patients to overdose. The most common student error is dropping a trailing zero that is not acting as a placeholder. For example, the measurement of 1.20 centimeters should be recorded as 1.20 centimeters, not just 1.2 centimeters. Otherwise, we lose one significant digit, 1 degree of precision, and that affects all of our other calculations. Thank you.